In order for an organism to maintain life or to maintain homeostasis, you have to have certain factors in a set amount, I guess you could say. And we call these survival needs. Okay, so the first one up is oxygen. So oxygen is needed for basically for cellular respiration. So a lot of times if I ask students, what do you need oxygen for? They say to breathe. Well, no, technically no, it's not to breathe. Breathing is just the method of bringing the oxygen to into the body and into the lungs so that then it can be delivered to the cells. So the cells are going to use the oxygen for cellular respiration. And if you remember, what's the whole purpose of cellular respiration is to make ATP, and that's the fuel that the cells use. That's the energy form that the cells need for everything that they do. Nutrients are also a survival need. You need to ingest food in your diet in order for your body to break down these substances and to use these chemical substances for energy and cell building. So yeah, you have to eat. You actually need water more than you need food. You can't survive very long without water. You can survive longer without food. Water accounts for about 60 to 80% of our body weight. It is the single most abundant chemical substance in the body. So if you think about it, what do you need water for? Well, if you think back to Bio 107, water was often a reactant, and it broke chemical bonds through the process of hydrolysis. So I'm not going to get into it, but you should remember that from Bio 107 or the prereq to this course. So it's often a reactant in many chemical reactions that occur in the body. For normal body temperature, like a lot of people don't realize that this is considered a survival need, that it's absolutely necessary to maintain a homeostatic body temperature. So here you have 98.6, that's on the average, the homeostatic level. If your body temperature increases and you're moving beyond that, once you get to 100 and you move past that, then that's considered a medical emergency. Why is that a medical emergency? Think about what you know about how enzymes react to heat. So the enzymes are going to become denatured, and they're not going to be able to carry out their function, which is to catalyze or speed up chemical reactions. You have hundreds and hundreds and hundreds of enzymes in your body that catalyze all the different metabolic reactions or chemical reactions that are occurring. And if the enzymes, if your body temperature gets too high, then the enzymes become denatured and they cannot do their job. It is also life-threatening if your body temperature decreases. So if your body temperature decreases below 97 and starts drifting towards 90 degrees, then that also is life-threatening. Think about what you know about the movement of molecules when the temperature is cold. So when the temperature is cold, the molecules become sluggish. There's less likelihood for them to bump into each other. So less likely for chemical reactions to occur. The last survival need is an appropriate atmospheric pressure. Basically, in order for you to inhale or breathe air in, you have to have a pressure gradient created. So you have the atmospheric pressure outside of your lungs. You have interpulmonary pressure within the lungs. Who cares about that name right now? So the air is going to move from an area of high pressure outside the lungs to an area of low pressure in the lungs. And that's essentially how you inhale or breathe air in, is basically as a result of a pressure gradient. How you exhale to get rid of the carbon dioxide is that the pressure in the lungs is greater than the pressure out here. So the air is going to follow its pressure gradient and exit the lungs. But don't you worry, we're going to cover that in so much more detail when we get to the respiratory system.